Welcome to solverfy.
All right, so we are drawing molecules and determining if they have optical activity. All right, so starting with A, we have one pentene. All right, so just to draw the pentene first. All right, so the first one pentene, just like that. Now this does not have optical isomerism, and the reason for that is simply because you have essentially two hydrogens off the edge like that. Since they are the same substituent, you can't really measure cis or trans to the hydrogen because you're simultaneously going to be cis and trans to the hydrogen. So that's not very helpful. So yeah, that's just the only structure you can get from this is just one pentene. All right, moving on to B. All right, so you have two pentenes. So drawing the same 5-carbon structure, except this time doing it at the second carbon like that. All right, so now this does in fact have cis-trans isomerism, and the next molecule you can draw to prove that is that, right? So if I wanted to name these two structures, this one is going to be E, 2-pentene, and this would be Z, 2-pentene. Okay, so moving on to C, I have 1-chloropropene. All right, so the propene is just going to be a 3-carbon chain. 1-chloro is going to be like that, and that will be the double bond. This will have cis-trans isomerism because I can additionally draw something that's going to look like this instead, right? Where the highest priorities are both on the same side. In this case, this would be the Z isomer, so Z1-chloropropene. And this would be E1-chloropropene. All right, so moving on to the last one. It's going to be D. This is 2-chloropropene. So again, drawing that same 3-member carbon ring, I have 2-chloropropene, so it's going to look something like that. Now this will not have optical isomerism, and the reason for that is I have 2 hydrogen right here. And similar to part A, I can make the argument that it doesn't really matter if this is organized like this, or if I wanted to flip the orientation of the methyl and the chlorine like that, because these are the same molecule. Even rotation about the double bond produces the exact same thing, because both of these are, when I say these, obviously meaning the substituents, the chlorine and the methyl, they're simultaneously cis and trans to the hydrogen. So it's not really helpful, nor is it important to name these things as cis or trans. So the only structure you can draw here is just 2-chloropropene.